Hi, welcome to R&AC Academy. My name is Ram Prasad. Let me give a small brief about me. I did my masters in R&AC and then I worked for 25 years with the various organizations involving in product development and technology innovation functions. I had 5 patents filed on my name. Out of my passion, I transitioned into teaching. Presently, I am into coaching GATE and IES aspirants on R&AC subject. I also conduct workshop on R&AC systems, faculty development programs, etc. for the engineering colleges. Recently, I conducted webinars for the members of ISHRE and ASHRE. Coming to this program, I am presenting here with a series of lectures on refrigeration systems for the benefit of the students and professionals. I believe these lectures will be of great help and learning to all of you. This is the 8th lecture in the series of lectures on refrigeration systems. In this lecture, we will discuss about the volumetric efficiency of the compressor. Let me start with a small introduction. This is the piston arrangement and the piston will be reciprocating inside the cylinder between TDC and BDC. The inner diameter of the cylinder, also called bore of the cylinder, and the distance between TDC and BDC is called stroke. When the piston is at TDC, the volume of the cylinder above the piston surface is called clearance volume. And the volume of the cylinder between BDC and TDC is called stroke volume, swept volume or piston displacement. Let us plot what happens with this arrangement on PV coordinate system. All activities related to this piston cylinder arrangement of the compressor happen within certain limits. On the pressure side, the limits are PD and PS. PD, nothing but the discharge pressure, and it is synonymous with condensing pressure. PS is nothing but suction pressure and it is synonymous with evaporating pressure. On the volume side, the limits are TDC and BDC. This is the clearance volume and this is the swept or stroke volume or piston displacement when plotted on PV coordinate system. Let us say this is the state of the refrigerant. Right, and let us number that as 1. The refrigerant at state point 1 is at pressure PS and the piston is at BDC. And when piston started moving towards TDC, then the pressure of the refrigerant will start increasing. When the state point 2 is attained, the refrigerant pressure reaches PD. However, the piston hasn't reached the TDC yet. So, any further movement of the piston towards TDC beyond state point 2 would not result in increase of the pressure of the refrigerant. Instead, the refrigerant at pressure PD would start get discharged into the discharge manifold. And when the state point 3 is attained, the piston reaches TDC. When the piston is at TDC, the refrigerant vapor exists in the clearance volume at pressure PD. Because of this, when the pistons start moving downwards towards BDC, there won't be any fresh refrigerant vapors inducted into the cylinder. Instead, re-expansion of clearance gases will be happening. After attaining the state 4, any further movement of the piston towards BDC will result in fresh refrigerant vapors from the evaporator inducted into the cylinder. And this volume is called actual volume sucked Also, we can say this is the actual volume of the refrigerant vapor inducted into the cylinder. We saw that Vs is the actual volume of the refrigerant vapor sucked into the cylinder. Then we have the actual volume of the vapor sucked into the cylinder per second is equal to Vs into n by 60 into K expressed in meter cube per second, where n is the RPM and K is the number of cylinders. We had also seen in the lecture number 4 the actual volume of the refrigerant sucked into the compressor per second as m into V1 expressed in meter cube per second, where m is the mass flow rate of the refrigerant in kgs per second and V1 is the specific volume of the suction vapor corresponding to state point 1 expressed in meter cube per kg. So, by equating these two, we have Vs is equal to m into V1 divided by n by 60 into K. Now, let us define volumetric efficiency. It is a ratio of the actual volume sucked divided by the swept volume, and it is nothing but nu V is equal to Vs into Vp. By substituting the expression for Vs, this is what nu V is equal to. So, this would resolve into m into V1 is equal to Vp into n by 60. Vp is swept volume or piston displacement multiplied by n by 60 into K multiplied by volumetric efficiency. A useful expression in computations or numerical calculations. Let us now look at how the volumetric efficiency is influenced by the change in suction pressure. For that, let us take up a baseline cycle 1, 2, 3 and 4. And for this baseline cycle, the actual volume of the refrigerant vapor sucked into the cylinder be Vs. Let us now increase the suction pressure from Ps to Ps dash. That means the new cycle will be operating between Pd and Ps dash, and the new cycle will be 1 dash, 2 dash, 3 and 4 dash. The actual volume of the vapor sucked into the cylinder for this new cycle is Vs dash, which is more than the baseline value Vs. That means when the suction pressure is increased, the actual volume of the vapor sucked into the cylinder increases and hence volumetric efficiency is increased. Let us now decrease the suction pressure from Ps to Ps double dash. That means the new cycle is operating now between Pd and Ps double dash, and the new cycle will be 1 double dash, 2 double dash, 3 and 4 double dash. And the actual volume of the vapor sucked into the cylinder is Vs double dash, which is lower than the baseline value Vs. It is because more portion of the stroke length is consumed for the re-expansion of clearance gases. Therefore, with the decrease in suction pressure, the actual volume of the refrigerant vapor sucked into the cylinder reduces and hence volumetric efficiency also reduces. To sum it up, with increase in suction pressure, the actual volume sucked into the cylinder Vs increases and hence the volumetric efficiency increases. Let us now look at how the volumetric efficiency is influenced by the change in discharge pressure. In this case also, let us consider the baseline cycle 1, 2, 3, 4 and the baseline actual volume of the refrigerant vapor sucked into the cylinder be Vs. Let us now first decrease the discharge pressure from Pd to Pd dash. That means the new cycle is operating between Ps and Pd dash. The new cycle will be 1, 2 dash, 3 dash, 4 dash, and the actual volume of the vapor sucked into the cylinder Vs dash, it is more than the baseline value. Therefore, whenever the discharge pressure is reduced, the actual volume of the vapor sucked into the cylinder will be increased and hence the volumetric efficiency also will be increased. Let us now increase the discharge pressure from PD to PD double dash. That means the cycle is now operating between PS and PD double dash. The new cycle will be 1, 2 double dash, 3 double dash and 4 double dash. And the actual volume of the vapor sucked into the cylinder Vs double dash is lesser than the baseline value. It is because the more portion of the stroke length is consumed for the re-expansion of the clearance gases. Therefore, whenever the discharge pressure is increased, the actual volume of the vapor sucked into the cylinder will be reduced and hence the volumetric efficiency also will be lower. To sum it up, with the decrease in discharge pressure, the actual volume of the vapor sucked into the cylinder Vs increases and hence the volumetric efficiency also increases. With this lecture is completed, and in case you have any questions, doubts, etc., please feel free to write to me. The next topic in this series is vapor absorption refrigeration system. See you then. Thank you very much.